Good morning, YouTube. Working on the 3D printer today. So the last few days I've been trying to print some of my battery holders, and one of the problems I ran into, I printed one of these, it worked just perfect. After that I tried printing some more, so I would get up here between an 1/8 and a 1/4 inch. The extruder would start going over and it was no longer sticking to the part, and then it would fail. And I tried changing all sorts of settings. After trying all that, I finally decided it was probably this extruder cooling fan. And if you listen here, it's pretty noisy. This fan's always been a little bit noisy when it first starts up, but it always worked, so I never bothered replacing it. But there's two screws. There's one at the top corner and then one at the lower right corner that you have to get out, and that was so hard to get to, I just kind of kept putting it off. But I finally ordered 3 extra fans from solid state printers to have some spares. This one is still working. Now I normally print ABS, so I'm not using the part cooling fan, but with these battery holders I've got a bunch of PLA filament, so I'm using that instead. And with PLA, you need the parts cooling fan. That was working, but this was not, and this whole hot end was getting very hot. I think the fan turns on at 50 Celsius. Yeah, there we go. I couldn't even hear it. I wasn't feeling any air blowing out of the front. The funny thing is the fan was spinning. You could see that the blades were moving, but it just wasn't fast enough to move any air. So I think we're good to go now. Yeah, I've been fighting this for a couple of days, thinking that I messed something up with my slicer. So now I've got to go back and undo all the settings that I was trying. But yeah, I guess that fan must have died a couple of days ago. One part printed just perfect, and then the next one didn't print at all. But let me show you one other fix that I've done here. I guess this is called the X cable, because it's the X axis. It's a flat flex cable here. I've had problems with the cable flexing a lot during printing, and I had one of these fail, so I had some custom cables made. I got the cables a little bit longer, so there was a little more room for the cable to flex over here, so it doesn't bend quite as tight. So there we're going. Let's see if we can move out here. We'll go over, up. So even if I go all the way over. But yeah, I think the little bit longer cable gives it a little larger radius on the curve there. And you can see the other thing I've done, because that cable normally just came out of the connector there, and it was supported over here, and all the weight of the cable was hanging there. And actually I think the problem is it puts stress on this connector here, and it was actually the contacts on the flat flex cable seemed to get chewed up. And that's where it seemed to be the problem, because you could unplug this and plug it back in and it would work for a while, and then you'd unplug it, press it back in. And I think it was just stress on this connector, because all that weight of the cable was being supported. The cable was twisting this way. Okay, so to try to support this cable a little bit, I made this cable support there, and I found there's a gap between this white circuit board that the motor mounts to, and then there's another circuit board on the back side that all the cables plug into. You can see there's the motor cable, the X cable, and then there's the Y cable back there. And there's about an 1/8 of an inch gap roughly. So yeah, what I did was I measured that out, and I cut a little cardboard template here. So overall this piece is about 8 inches long, and the vertical spacing between these two sets of holes is about 2 1/16 of an inch, and then horizontally here between those two holes on the bottom or the two on the top is about 1.5 inches. And the standoffs are roughly 1/4 inch, maybe 6 millimeter. So I made up a cardstock template here. I think this was probably my second version. And what I found is I needed to come up about a 1/2 inch higher than this line. And you can see there, I came up right about the top of the circuit board with the bottom of the support. And then I went up an inch above the top. The reason I went up that high is you've got the stepper motor there in back, and then you've got the fan cables and the stepper motor cables are all down here. So I wanted to keep the cable support above the level of the stepper motor so that there's clearance so it can move back and forth. For this, I was going to 3D print a part. I found I had a piece of generic perf board, so it's a circuit board material, and I had a piece 8 inches wide, and that turned out to be absolutely ideal. So I just used my template and laid it down on the circuit board material, cut it out, and then I put the copper side of the circuit board towards the back, and then I soldered 2 wires on there to support the cable. I just put the copper wire on and then bent them so that the 2 wires roughly bend at the same level as the cable comes out of the connector there. As you can see now, it supports it all the way across and keeps the cable up off of the bed. So if your part you're printing is up here, it keeps the cable free. You fit it in like this, and then you catch that upper standoff with this hole, and then you have to trim it really carefully to fit over the bottom standoff, and then that's what locks it in place. So it's just held in there by gravity. So I can't see if there's any bare circuit board traces on the back side circuit board. But what I did was I just wrapped my PCB material in electrical tape. That had 2 functions that turned out to be really good. One is it insulates that copper side so there's no potential short circuit. And then I was also able to build up the thickness by putting a little tape on this side so that it really jams in there tight. When the printer is vibrating and doing a lot of fast movements, I don't want that piece falling out of there. So yeah, that's been working really well. The only thing I have to watch for is when I feed in new filament over the top. I generally have to reach into the back and pull the filament out of my filament guide, and every once in a while I'll end up knocking the ribbon cable out of that loop back there. So I just have a hook bent on the end of the wire. When I change the filament, check that the ribbon cable is still up in there. It's not firmly secured, it just sits there because I don't want to put any stress on that cable. The length worked out perfect. Like I said, it was an 8 inch wide perf board. 2 inches gets used up in behind the stepper motor, and then that brings the edge of this out to 6 inches. And since the build plate is 12 inches wide, that gives support out to halfway, out to 6 inches, and then you've got 6 inches of cable here to move around. So when you come all the way here, there's still a loop of cable there. It's not pulled tight, and you can see everything's just nice and loose, but it's supported. Yeah, if you have one of these Type A machines, Series 1 or Series 1 Pro printers, I think this will really help with the X cable wear. The nice thing is this moves with the Y-axis, so it comes back and forth. It's never going to be in the way of anything moving side to side because it moves with the print head on the overhead beam there. So it took me quite a while to figure out exactly how to support that, and I've been running this now for probably a month or 2 and no problems with it yet. So I think that's a really good upgrade. I'm surprised they didn't do something like that from the factory, because there was a lot of stress on that cable just hanging there. and it was wearing out the connector right on this end. I think the cable itself was fine. It was just this male connector that plugs into the circuit board was getting chewed up. The old plating was getting worn off the contacts, and it was just the stress right at that connector from all the moving side to side and the vibrations. And this is the ticket to these printers. Keeps your cable out of the way and everything works really nice. So I got to get back to printing here. I've got to take my model here and undo all the changes I'd been making and get a fresh model and then try to reprint this. So yeah, I'll try to come back and give you an update on how the print worked there, and we can check it out.